Good day, viewers. You are welcome. How to solve these nice functional equations? We are given f of x plus 1 equals x raised to power of x. So we are interested to find the inverse of a function which is f inverse of x minus 1. So this is an interesting functional challenge, and before I solve this, if you know how to solve it, we can just drop it in the comment box. So let's get into the full solving of this. Let's consider the solution first. The question says f of x plus 1 equals x to the power of x. Note that from here, the value of x is greater than 0. That is the first condition we have to note. And we want to find the inverse of this. What to do first is, I want to reduce this domain to just single value inside. If I let y to be equals x plus 1, then we make x the subject so that we have x equals y minus 1. And by replacing every single thing, we have f of y equals, we are going to have bracket y minus 1 raised to power of y minus 1. Let's replace y with x. So by replacing y with x, we have f of x equals x minus 1 raised to power of x minus 1. Then we want to find f inverse of x minus 1. Let's consider this as step 2. Note this as step 1. So in this step 2, we want to find f inverse of x minus 1. So what to do is, suppose I let the whole of f inverse of x minus 1. If I let the whole of this to be u, let u to be equals f inverse of x minus 1. So if I introduce another function to this, suppose I have f of u to be equals f of f inverse of x minus 1. And when f and f inverse multiplies, they cancel each other, as we have only f of u equals x minus 1. So if f of u equals x minus 1, definitely when we come back to this, where we have f inverse of x minus 1, so introducing this function to this stage, f, we are going to have our f of u as well to be equals x, that is going to be equals u minus 1 raised to the power of u minus 1, as this is what we have. So just like we have above, f of x equals x minus 1 raised to the power x minus 1. We also have f of u equals u minus 1 raised to the power of u minus 1. And from this stage, suppose I let v to be equals u minus 1. We are going to have, and from here, our f of u from the above, we have it as x minus 1. So in replace this, we have u minus 1 raised to the power of u minus 1. This is equals x minus 1. And to reduce the large number here, that u minus 1, if I replace this u minus 1 with another variable, suppose I let u minus 1 to be equals v, and u here also equals v plus 1. Then we are going to have here as v raised to the power of v equals x minus 1. I want to apply the Lambert W functions. That is the whole of this process. So this stage, it will be easy to find, though we can also apply it at this stage as well. But let's make it short like this. Here we are going to introduce the natural logarithm, which is ln v raised to power v equals ln of x minus 1. And by root of logarithm, so this v comes down, we have v ln v equals ln of x minus 1. And we should note that if you have ordinary v, we can write this thing as ln v multiplied by e raised to power of ln v. For exponent and logarithm, they cancel each other. So just a manipulation, and we have this as ln of x minus 1. Then let's introduce the Lambert W function here at this stage. So suppose we introduce w to both sides, which is omega. We have ln v e raised to power of ln v equals w of ln x minus 1. So the rule here is, suppose we have w of a exponential a, this equals a. And ln v and what is at the power of exponent, they are the same, which means we took only ln v. So by taking that, we have ln v equals w of ln of x minus 1. And we need v here. Let's introduce exponents to both sides. Here we have e raised to power of ln of v equals e raised to power of omega of ln x minus 1. Then this cancelled. We have only v here. So we have v, but v is given as u plus 1, which is equals e to the power of omega of ln x minus 1. And we have this as u minus 1. So when we take 1 to other sides, we have u equals 1 plus. But e raised to power of omega of ln x minus 1, it also has an identity, and the whole of this one is given as ln x minus 1 divided by the omega of ln x minus 1. So this is the result of, when we have e raised to power of omega of z, we are going to have z divided by omega of z. So that is what we apply here. And this is the final answer to this. Don't forget that our u here is given as f inverse of x minus 1. Thanks for watching, and see you in the next video. If you have any other comments, any additional subtraction, you can just drop it in the comment box. Thanks for watching, and bye bye.